Morning. My name is Tomoya Fujita from Sony Japan, and we're going to talk about aibo and ROS today here. And first, I got to say thank you very much for your cooperation and effort for everything you did, and the open source community and everyone involved in this mission. Thank you very much. We really appreciate that effort. And again, I'm from Sony Japan R&D Center. I'm a software engineer, most likely working on the system services, like middlewares like ROS, and sometimes kernel. And ROS is one of the open source which we used for aibo. Okay, let's talk about that today. We can't see that. Yeah. Okay. Okay, so the question is, how many of you know aibo? Oh, like, I didn't expect that's coming. Okay, like everyone, okay. So first, I need to apologize that aibo was shipped out from Japan to be here, but something happens in the customs, so he's got in custody in the Madrid airport. So I'm sorry about that. But instead of that, I'm going to show you the quick video to, describe what the aibo is. Okay, so the aibo is the home entertainment robot, and it's also the autonomous robot that brings us emotional bond to you owners. And it's not a prototype, it's a product on the market in Japan, and that's the actual product. So what's important for now is we use ROS for that. That's a great thing. And let me do some quick ads here, because I got too much pressure on me from the management. So that's aibo. Oh, sorry. Cannot see that. Okay, that's aibo. The product name is ERS-1000. And it's already out there in Japan. Okay, and it's coming up in US very soon, so you can book it. Actually, you can book the aibo for now, so you can do pre-order. So if you are interested, please try out aibo. Thank you very much. And so aibo, I'm going to talk about the concept. aibo comes close to you and makes interaction with you very positively. That's a whole new concept or difference, you could say, against, compared to the consumer devices, like a TV does not come to you. Or maybe you have the audio agent. The agent is just waiting for your command to wake up, right? So that's, like a difference the aibo has. And this is the architecture we have. On your left bottom, a lot of sensor data comes from the physical sensors. And sometimes, if necessary, we have to do refraction. If we touch something really hot, we will untouch that immediately without any thinking, right? So that's a reflection. And the sensor data is processed to recognition and understanding the situation or environment, to do the intelligent process. We do some, process on the edge, but aibo is also connected to the cloud. So we can do, if the workload is heavy, we can do the process on the cloud server and bring it back to the edge, and we can do the behavior planning and make actual motion to the user. And this architecture, we believe, is not only for aibo, but also the other robots we are trying to. Okay, this is the product design and the concept before we start development, any development. And first, we define aibo area for making a good communication. So based on this design, we choose the physical sensors and what kind of perceptions aibo should do or something like that. This is a start. This is the very beginning of aibo. And you can see the feeling area. aibo can feel somebody or something. He has no idea about who it is, but he can realize somebody is there. And he can try to get attention in the attraction area to like make quick reaction because somebody is there. And after that, aibo can communicate with user or owners. This step is just to make natural communication for aibo. Okay, this is platform. We use for the application processor, the Qualcomm Snapdragon 820. The product name is APQ1896 because they have a lot of experience in the mobile market, and they have good features for audio system and the sensors. So we chose to use the Snapdragon, which is the most advanced chip in the world. So, and on the left, you can see the bunch of sensors connected to the application processor. Yeah, the 2 cameras and TOF, and touch sensors, and microphone, PSD, motion detector, ambient light, IMU. And on the right, we have total 22 actuators, our specific actuators, directly connected to the motion processor. So we can have the real-time action here. Okay, this is a list of sensors. I'm not going to mention all of this, but we have 2 cameras on the front face and back, and that's a fisheye camera because aibo needs some wide angle to see somebody who is standing right in front of him, right? So aibo is like this big, and he's on the floor, so he can see that with that wide angle of somebody's face. And also we use the back camera for the slam. aibo can slam on the edge. There's no upload to the cloud. And so he can make mapping, and he can get back to the charger station in the house. And also we have like object detection and the cliff detection and lift up or human detection, something like that. Okay, let me talk about the speech recognition here. aibo has 4 mics available, and local sound source direction and the speech recognition, everything is done on the edge. There is no need to upload PCM data to the cloud, so everything is done on the edge. This is also cared for privacy, of course, and the commands available, just like dogs do. If you have dog like a sit or stay or something like that, you can say it, right? So aibo can understand that commands, but there is no wake-up command. So the aibo that regularly and constantly does a speech recognition only to make natural communication. So there is no wake-up command for aibo. The aibo also, we have our own specific audio technology because we have a lot of experience for the audio. So we use that technology for that aibo, for the digital signal processing and the speech recognition. And this is, I'm going to talk about tools from here. This is the one tool that is Cohesion View. And it's one of the tools developed by us. And during development, it is really important to, you can see what's going on inside aibo in the real time. So we need a tool to see that. So this is one of them. So you can see the cognition status of aibo in real time. And you can see the circle. And the circle is exactly what I mentioned before, the design. That's the whole concept. So we can see with this tool if aibo system goes with what we designed exactly. So this is pretty much important for debugging. Okay, this is ML data collector. ML stands for machine learning, and with this tool we can get the sensor data from the aibo. Of course, the recording is supported, so later we can play back the sensor data for aibo. And this is what we called, what is called is a neural network console. And it's really common to use the deep learning for the recognition, right? So, and we have our own open source library and the console. That is the Sony Neural Network Console. This is a console. So with this tool, you can see the network just like that. And even it can optimize the network automatically. And like I said, this is already open source and it's open public. So if you are interested in like AI programming or deep learning, you can happy to check that. It's worth to give it a shot. Yeah. And all of the training for the recognition is done offline. We don't do anything, any training on the edge. So we have everything trained on the server, and we deploy that network to the edge on aibo. Okay. This is, anybody familiar with gaming? Yeah? No? Okay. This is, it just looks like a behavior editor. And it's really common for gaming. And this is, maybe some of you already realized, this is a Unity custom plugin. And describe behavior tree to connect each motions which is created by the motion creator. And we can, with this tool, we can make the whole one behavior from some motions. And this is also the Unity custom plugin and model to make motion. So far, no plan. We got a lot of questions if we, expose this, plugin and make model for the open source, but so far, no plan to do that. So this is used by motion creator most likely, and since they are not software engineer, so it's pretty hard to use gazebo. So that's why we made this tool for them, so they can make a lot of motions with this tool. And this is a screenshot from the apps on the smartphone. You can, as you can see, you can teach some tricks like motions, and of course you can make him forget about that. And of course you can do some system setting like a Wi-Fi or cameras, pictures. You can see that on the apps. Okay, we have the ROS boundary between some system daemon. For example, here, like eyes, eye daemon, and sound mixer. And the motion processor is not a ROS node. It's a different hardware and connected to the, like actuators. And the body controller is ROS node running on AP, communicate with the motion processor, and the motion processor controls actuators. The boundary is for real time. I think you already understand that from this picture. And for the behavior, which is based on eye, speakers, and motions, because they has to be synchronized. If, for example, like if they are not synchronized, aibo seems to be barking, but sounds comes after like 5 seconds. It does not make any sense. So for the real time, we designed this architecture. Okay, now we have, of course, we have the experience for the mobile platform like security, wireless, camera, and sensors. And aibo has also AWS IoT and the AWS connected to the AWS cloud. And we use ROS for aibo, but it's still a challenge for us to use ROS for the product. But I'm from R&D, and we think we should give it a shot. That's for us. That's a challenge for us. And we did put everything together. That is aibo. Okay, now we have been talking about the aibo so much, and we did some embed optimization for aibo. So let's talk about that from here. Okay, before moving on the main topic, let me explain how it works for the ROS transport layer. If you are ROS application engineer, like you don't need to know anything about this. It's perfectly concealed by API, so maybe you don't need to realize that. But for my explanation, let me explain that first. There are two types of connections. One is XML RPC, which takes care of the configuration data, such as who publishes or subscribes on which topics or services. And that's the XMRPC. And it's not important for now, because that happens like only boot time. Once your ROS system boot comes up online, everything should be done. The configuration has been done. So there is no activity for the XMRPC, most likely. Of course, the second one, which is TCP ROS and UDP ROS, is important for us, because this takes care of the user data payload. So, which means every single time you publish the data, or if you're on the other side, you receive the data, you're going to have to use TCP ROS or UDP ROS. In default, you use TCP ROS. So the point is, every single time, as long as your ROS system is running. Okay, so what is the problem? CPU stress and latency and throughput. So, like ROS is pretty good for the packages and the build tools and documentation, but it's not good enough to be optimized for the CPU consumption and the latency for the embedded system. So we focus on the TCP ROS to enhance it. Because like I said, if we can optimize TCP ROS, we can take advantage of that every single time you publish the data. That's a huge, like optimization for us. So for optimization, the priority number one policy is for us is do not break the user space. So that's, if you are dealing with a system layer, that's the priority number one. You do not break any user space. So we think we should have good affinity with the TCP ROS, and with that, small latency and high throughput, and no change required for the application. Okay, this is expected improvement as for the system typical number. And we have the Skylake for AMD 64 and the Hikey ARM64. And as you can see, for the Skylake, the latency is 1.7 times faster, and Hikey 2 times faster, and throughput, and for Skylake 4 times improved, and for Hikey 10 times. That's really good optimization for system. This is just system typical number. So this is not what we get on the application. I'm going to talk about it later. Okay, this is the current communication we have for ROS transport layer. And even if the connection is system inside, you're going to have to use TCP IP socket anyway. So there's no way you can do. But with our fix, you don't need to do that. Everything is done using Unix domain socket in the kernel. We don't go down to the IP layer. So the socket layer is the API is really good affinity, for Unix domain socket or TCP ROS. Okay, this is what we get improvement as a result for the application. This is a hello world benchmark, and the result comes up like for Skylake, 8% improved. This is latency. And the Hikey is 24% improved. That's a good number. And you don't have to change any single line of code for the application. All you have to do is rebuild the ROSCon and put it into your, into your system and reboot. That's all you have to do. You don't need to know anything about that. And the source code is ready. It's kinetic dever, and I already made a pull request for the main line. And we understand the current code that includes unnecessary changes. Of course, the final commit is there's no conflict to the main line, but we can see some difference between the Git difference. So, but we understand that, but we like to know if anyone is interested in this fix. So if any request comes up to us, we are willing to adjust code to the main line, of course. So if you are, interested, please make sure give us the stars on the GitHub. Okay, from now let me introduce some patches which we use for aibo. they were so useful. First is direct I/O with ROSbug. Sometimes we use ROSbug for the debug, right? And but ROSbug itself sometimes stores CPU, and that causes us we cannot reproduce the issue again. So that's a huge pain for us for debug. So we don't like that. So with this patch, we use direct I/O without CPU power. So it's useful for us for debugging. And aibo, this is a really good patch on the it's open source, and for the latest Kinetic, it's already merged in. So, but this is really good. A poor system code is not good enough for if you are dealing with a lot of file descriptors, because you need to check if the event is ready or not to scan the file descriptor on the user space. It's a huge pain for the application. But if you use aibo, everything is done in the kernel. So you just check the event, and you can process whatever you do. And polling frequency. ROS nodes makes a lot of threads inside a core library. And there are main threads, and the poll manager, and XML RPC manager, and the ROS out thread. And that's gonna stress your platform. So we make a tunable, like an environmental variable to set the polling frequency so you can set the timeout for each processes. I mean the ROS nodes, and we have our own logging system. So we don't make any ROS out threads, nothing for this. Okay. Finally, for ROS2, they have been talking about ROS2 like a DDS on yesterday, and we are working on ROS2 DDS implementation layer, so you can create our own implementation that's going to be much faster, specified for embedded system and optimized, and it's under consideration. But we are working on that, and we hope we're gonna expose this fix maybe for future. Okay, again, thank you very much for your cooperation and everyone in this room and everyone involved in this mission. And we really appreciate for your support. That's why we made aibo. Thank you very much.
Thank you. Does anyone have some questions? Looks like we got a question.
Can you tell me which processor used for motion control?
Oh, that comes from you. Yeah, let's put it in that way.
Thank you very much. It's good to know. I'm from Renesas.
So I was curious, you kind of went quickly over the patch to ROSbag direct write. Is that going to be open source, or is there a pull request for that?
It's open source.
Okay.
Yeah, it's out there. We found that patch because ROSbag stores our CPU. So.
Oh, you mean, okay, I thought you had changes to it. You mean you just found the package? Is that what you meant?
No, not package, patch.
Oh.
We backported it.
Oh. I'll talk to you later.
Okay, my question is not about technique, it's about business. What kind of language this aibo can recognize? And that is how much, if you're talking about online order?
The language is Japanese, of course, and English. And I missed the second question. Sorry, can you repeat that?
Can recognize English?
Yeah.
Okay, good.
Yeah.
How much, the price?
The price? The price, I guess, for US, I think almost $2,000 for aibo. Yeah.
Any other questions? Okay, thank you.
Thank you very much.